Now we'll get started at creating the coroutine to control the motion of the curve over time. So the first thing I'm going to do is to completely remove this update function, because we're not going to be using this. We're going to be coding the motion not in the update function, but we're going to be using a coroutine. So I'm going to create that now, and we have to put in the all-important IEnumerator return type, and I'm going to name the coroutine travel to indicate that it's going to be coding the traveling information for the box. And we're going to be using all of these variables that we have created here to control the motion. So the first thing I'll do is create a local variable which is going to be called elapsed time, and this will allow us to keep track of the amount of time that has elapsed since the beginning of our traveling. So right now we're going to initialize this to a value of 0, and what I want to do is to keep repeating our code until the elapsed time has passed the total time. So we have elapsed time less than total travel time, and that's the value that we have here. So while we have not exceeded the total travel time, then we want to keep traveling. Now the first thing we want to do is to calculate what the x position of the box should be. So what its position should be on the x-axis. And we know that this value should be generated using the curve that we constructed in the graph. So to do that, I'm going to build this x position value here. So I'm going to hold this xpos, this local variable, to temporarily hold the x position of the cube. And we have our x curve property. Now I'm going to just Control-C that to copy it and paste it into here, and press the period symbol. And we have this function here, evaluate, which returns a floating point value, and the input is a floating point value. And what we effectively are doing is we are inputting a time, and what we get out is the corresponding value on the y-axis. So on the vertical axis, we input a value on the x-axis and we get out a value on the y-axis. So it interpolates those values. So I'm going to type evaluate like so, and we're going to be passing in the elapsed time divided by the total travel time. And what that will do is it will give us a value between 0 and 1 that will allow us to pick out a value on the graph. So I'm going to also scale this value by multiplying by the x range value. So we've got our x range value, and I'm going to be multiplying this by the range, since we want to control the deviation on the x-axis by this x range property. So this will act as a kind of scaling value. So this generates the position for the box on the x-axis. The next thing I want to do is to actually update the position of the box, and we've seen how to do this before using the transform component. So I'm going to type transform dot position dot, actually beg your pardon, not dot, we're going to say equals, and we're going to equal a new vector, and it's going to be a vector 3. Now we know the x position of the cube should be this position here that we have just calculated. So I can just pass in the xpos for that there. I don't want to change the position of the cube on the y-axis at all, so I'm just going to leave that completely intact and pass it its y value position and leave that completely unchanged. The next thing I want to do is I also want to move the cube forward on the z-axis by its travel speed here. So to do that, I'm going to type transform dot position dot z plus the travel speed that we have here, and we're going to be multiplying that by delta time, and that will move the cube forward on the z-axis as well as translating it on the x-axis. And then I want to return for this frame, since we have done everything we're going to do on this frame of the coroutine. And then when it returns to the function, I need to update the elapsed time by the delta time, so that here we're keeping track of the elapsed time, and this value is increasing, and it can end the loop as soon as it passes the total travel time. So what we have done here is we have coded the whole of our travel function, and the only thing that I need to do now is to initiate this coroutine, and I'm going to do that from the start function here. So all I'm going to type in here is start coroutine, and I'm going to specify the coroutine by string like so, and press Ctrl S on the keyboard, and there we have completed our code. Now we're ready to give this a test in the Unity editor. Okay, so now let's test out the animation path class and see how our coroutine interacts with the graph. So the first thing I'm going to do is press play on the toolbar here and observe the results in the scene. And you can see that immediately how our cube has just zoomed out of the view. So what I'm going to do is select the cube in the hierarchy panel, and I'm going to reduce its travel speed. Let's say I'm going to reduce this from 50 to 10, and then I'm going to press play on the toolbar. And now we're getting a much more sensible speed, and you can see in the viewport that already the object is zigzagging along our curve, and our curve is drawn here in the graph. But let's say that I wanted to make that motion more extreme. Well, we can use the X range value here to control that. So right now it's 10, but let's say I wanted to increase that to 50, and now let's press play on the toolbar, and right now you can see that motion is much more extreme and it's following the graph in a much more extreme way. So that's looking pretty good. I'm just going to bring that down a little bit to, let's say, 30, and now let's press play and see how that responds. And that's looking a little better. Now, of course, this is working absolutely fine, but what we can do, of course, is we can just come back into that curve, and I could completely just change the curve, so a flat line, for example, and let's just see how that now reacts. I press play on the toolbar, and notice that really the cube is not moving on that x-axis at all. It's just keeping that straight line as defined in the curve. I could create this kind of curve now. Let's just zoom out to see that in the graph, so that we can see that here. And let's just press play and just try that. So you can see how that curve's just looking there and working. So I could create another curve. I could completely change it to this kind of curve, and let's just see how that responds. Whoops, I pressed that in play mode. Notice that if you press it in play mode, the value will reset back to its original value before you press the play button. So that's important to keep in mind there. Let's just go back and change that graph to something like this kind of curve and press play on the toolbar. And again, you can see that motion taking effect here in the viewport. I could, of course, come back in and change the graph, add a few more keys, add a bit more zigzagging and extremities to this graph, like so. And again, let's just close that, press play on the toolbar. Again, right now you can see that taking effect here in the viewport. So that's how we can go about controlling the motion of an object in combination with curves. It really is a very helpful thing to do, and it's useful not just for controlling motion. We can program all kinds of values in this way.